Stanford University.
Okay, well, welcome to Lecture 4 of CS193P, Stanford, winter of 2015. So I've been doing all demo up until now, and now we're going to be doing all slide today. So I have a lot of stuff to talk about. Most of this, although not all of it, is covered in your reading assignments, okay? But here I'm going to try and highlight the things that are pretty important and also show you some stuff that's just not in that reading assignment that you kind of need to know. So this is definitely not a substitute for the reading. You'll still need to do the reading in order to kind of get the details of a lot of this stuff. So, but this hopefully will kind of get you focused in on the key stuff. All right, so first I want to talk about optionals and enums. So now that you know what an enum is, I can tell you what an optional really is, okay? An optional is just an enum. Okay, it's a very simple enum. It's a generic, kind of like array. You know how an array, you specify the type of thing in it. Optional is exactly the same. Okay, it's a generic. You specify the type of optional it is. And that type, which is T here in this little enum, is just the type of the associated value. You know that enums can have associated values. So that's just the type that if the optional is not nil, that's what you get. So that's all an enum is. And so, for example, this is what it would look like if we used the enum notation to do an optional, saying, you know, x, which is an enum, or it is an optional string equals nil, would just be saying x equals optional angle bracket string dot none. Okay? Or if you're setting it to not be none, you would say optional angle bracket string dot sum, parentheses, the associated value, which would be hello. Does that make sense? So optional is really actually super simple. The question mark and the exclamation point, I know that makes it seem like, whoa, it's really complicated, but it's pretty simple, really. It's just syntactic sugar to do this optional. Now, the unwrapping really just looks like this. It's just a switch. And in the case of sum, you give the value back. And in the case of none, you raise an exception. Okay? And simple as that. That's why it crashes when you unwrap something that's nil. Okay, so that's optional. All right, so array, I just want to, we covered this, so I'm going to go really fast through this, but arrays, the syntax there is the same, right? That square bracket thing, that means exactly the same thing. Also, you can't append or modify in any way an array that is a let, right? That's a constant array. I just want to make it clear that defining an array to be a constant by saying let something equal an array versus var something equal an array means that it's immutable. So you can't do append or insert or anything else that you could do on a mutable array. Also, of course, if you access an array with the square brackets and try to pull out something that's outside the bounds of the array, this array only has 4 animals in it and I'm trying to get animals 5, that's going to crash. Array index out of bounds, just like pretty much any language you've used. How to enumerate an array. If you wanted to go through every single item in an array and look at it, you can use for in. Okay, so you just say for some variable you want in your array, and then inside there, that'll be your value. Okay, pretty obvious. I put this here mostly to compare it to the next slide, which is dictionary. So dictionary, again, that square bracket thing is an alternate for the exact same thing. So if I had a nice dictionary here, I can create a dictionary using this square bracket notation, which is just square bracket, key colon value, comma, key colon value. Okay, you know that. And you also know that if I access a dictionary with the square brackets, it returns an optional. And that's because, for example, here, I'm looking up Pac-10 team Ohio State. Obviously, that is not a Pac-10 team, so it's not in the dictionary, so it's going to return nil. Okay, so that's why when you access a dictionary, it comes back, it's an optional. To enumerate a dictionary, you use a tuple. Okay, so you say for the tuple, key comma value, in the dictionary, and then inside there, key and value will both be set. Okay, so that's really easy way to enumerate dictionaries. Make sense? All right, I'm going to teach you about a new struct that you haven't seen called range. A range is just 2 points of a sensible type. So a starting point and an ending point is exactly what you would think a range would be. Now I say sensible type here because, you know, the sensible type depends on what you're talking about. For an array, the sensible type is an int, but for other things like a string, it's not, and we're going to talk about that in a minute. Range is also a generic, just like array or like that optional enum. And so it takes the type of thing. So the range, again, to specify a range in an array would be range angle bracket int, because ints are how you index an array. So if you were going to specify a range in an array, they would be ints, okay? And it's approximately what I put here. It's not exactly this, but as far as given what you know so far, this is the best I can describe it to you. It's just a struct that has a start index and an end index, and it is a struct. You can go and get those values and set those values out of there. So array's range would be array of int, range of int. String, you would think that a string would also be, subranges of strings would also be specified by an int, but it's not. There's a special type called string.index, which is an index into a string. I'm going to talk all about that in a later slide, okay? So ranges, just like arrays and dictionaries, we don't usually say range angle bracket int equals something. We use this special syntax, and the special syntax is this 3 dots or 2 dots and a less than sign. Okay, so the 3 dots means a range from the first thing on the left of the dots to the other thing on the right of the dots. That's the start index and the end index, and it includes them both. Includes both the start and end. Whereas the other one, 2 dot dot less than, means it includes the first one, but it does not include the second one. So it's an open-ended range. Okay? Because both of those kind of ranges are common. So that's how we specify a range. 99% of the time we don't use the range struct to do it, although you could create a range struct and you could pass it as an argument to anything that takes these dot dot dots. You could put an actual range in there as well. Okay, they're the same thing. It's just the dot dot dots are syntax to create that range for you. Okay, and the things on the either side of the dot dot dot, you know, it depends on what kind of range you're kind of creating. If you're creating an int range, a range of angle bracket int, then they'd be ints. Okay, but if you're doing a string, they have to be string.indexes. And that's a little harder to create because a string.index can't be created from a numeric literal. You have to create it programmatically. So we'll talk about that in about 10 slides or so. And you can enumerate a range using for in, just like we can with arrays and dictionaries there. Okay. All right, other classes besides arrays, dictionaries, range. NSObject. So NSObject was the base class for all Objective-C classes. In Swift, we don't really have a base class for all Swift classes. However, there are some kind of advanced features in iOS that require even your Swift class to inherit from NSObject. I can't really talk about them because there's other things you need to know for me to even explain them to you, but down the road that will happen. It really doesn't hurt to make your Swift class be a subclass of NSObject, so we could have made Calculator Brain be a subclass of NSObject. It wouldn't have hurt, and in the future, once we learn these advanced things, it'd be nice to be able to do those advanced features with Calculator Brain. So it's kind of one, you can feel free. I'm not sure what to say the best practice here is to always have your Swift classes inherit from NSObject. All the classes in iOS, like UI View Controller and all those, they all inherit from NSObject eventually. It's the superclass of all of them. There's not really much in NSObject anymore that matters. But like I say, there's these advanced features. But then there's NSNumber. You've actually briefly seen NSNumber. NSNumber is just a generic number holding class. It just holds a number. That's all it does. And it has a ton of methods on it. I'm not going to go through them here. You can look in the documentation. But the methods are things like double value, int value, which is give me your value of yourself as an int, as a double, etc. In Swift, we don't really use this very much because it's strongly typed, and so we're using types like int and double. But in Objective-C APIs, there's NSNumbers lying around. And so you kind of need to know about it. I'm going to talk a little bit later about the fact that all those Swift types are kind of magically bridged to NSNumber, okay, those ints and doubles. So you really don't even have to worry about NSNumber unless you're going to use something like the NSNumber formatter that we used in the assignment, okay, because that thing returns an NSNumber. Yeah.
So if there's Swift, is there a way to make like an array that holds any kind of...
Yeah, so the question is, if there's no NS objects, well, it wouldn't really matter about NS object, but the question is, can I create an array where there are random objects in there? And we're going to talk about that later. Now the class NSDate, exactly what it sounds like, stores a date, lets you get the current date and time too. Pretty self-explanatory, has lots and lots of methods in it. And it has even more and more methods because there's those three other classes mentioned here, calendar, date formatter, and date components. And if you're ever doing a date where you're going to put a date on screen as part of your application, you really want to look at all these classes and read the documentation that talks about dates, because dates are displayed very differently around the world. Different calendars, different, even different languages. The order of the month, day, year, even if you're using the Gregorian calendar, is different. So you really, dates are tricky to get right if you want to build an app that can work around the world. Okay, so I'm just kind of warning you, if you're going to build an app like that someday, you want to really understand date and all its friends here. There's NSData, super easy class. It's just a bag of bits. Okay, could be a gigantic bag of bits, small bag of bits, whatever, but it's just untyped data that's just in there. You can think of it almost like a pointer to memory, and you just don't know what's in there. This is how iOS will pass around untyped data, raw data. It passes it around using this class. It'll be obvious when we start using this what it's for. You're not going to be using NSData much in this class because we're not dealing with raw data that much. Okay. All right, so I just wanted to mention some of those classes just so you know they exist. You can check out the documentation on all of them to find out more about it. And I'm going to revisit a few of them like array and dictionary and string because they're so important. I'm going to actually talk about some of their methods. But I want to talk a little bit about data structures in Swift in general. Okay? There's really three fundamental building blocks for your data structures that you might build. And you've seen them, two of the three of them in detail. But they are class, struct, and enum. Okay, they're the three basic building blocks. And they look very similar. Their declaration syntax looks very similar, right? Just the only difference is whether it's class, struct, or enum, but otherwise looks the same. They're also very similar in that they can all have properties and functions. Okay, all three of them. Now enums, their properties can't store any values. You store the values in an enum in that associated information, but they can have computed properties. Okay, and all three of them can have functions. Right? Okay, so it's important to understand. So they're very similar in that way. They're also similar, at least structs and classes, in that they can have initializers. And we're going to talk about initializers in detail in a few slides. Okay, so they're similar in a lot of ways, but there's a couple ways in which they're very different. All right, classes are the only ones where you have inheritance. Okay, and it's pretty obvious. That's kind of the main definer of what a class is. It has inheritance. And then introspection and casting, which I'm also going to talk about a little later, those are only for classes. So none of this casting thing I'm going to talk about can you do for structs. And the most important difference to understand, and we really went over this in the demo, is this value type versus reference type. Structs and enums are passed around and stored in variables, copied, okay, and classes are reference types. In other words, we pass around pointers to them. They live in the heap. And remember that classes, their memory in the heap is managed for us. Okay, so there's nothing, we don't have to do anything. Alloc can free them. We create them when we want, and when no one's using it, it gets cleaned up. And it's not garbage collection, okay? Reference counting, automatic reference counting. But I want to just have a slide on this value type versus reference type again, because it's a really important thing to understand it, because people get confused writing the code and they don't really understand what's going on. But a value type, structs and enums mean that it's copied when you pass it into a function. It's copied when you assign it to a different variable. This one especially gets people, they don't understand this. If I have, let x equals array, and I say let y equal x, that makes essentially a copy of x. Now, that copy might be lazy behind the scenes, but as far as you're concerned, it's a copy. Okay? And if you want it to be mutable, you could copy it into a var instead of a let, and now you could mutate it. And if you mutate it, you're mutating your own copy. You're not mutating what the other one pointed to. Okay? Because of this, when you make a struct or an enum and you add a function to it that modifies it, you have to mark it with this keyword mutating. And that's so that Swift knows when someone else tries to use your enum or struct, if they use one of these mutating functions, it obviously has to be in a var, not in a let type variable. Okay. So reference stored in the heap, reference counted. Even if you have a constant pointer to a class, let something equals the class, you can still send messages to that thing that can mutate it because it's in the heap. All right, so you have a pointer to it. So, and when you pass it to a function, you're passing a pointer to that thing. So if the function modifies it, it's modifying the thing back where it was called. Okay, so which do you use between these two? Well, 90% of the time you're going to use a class. This is object-oriented programming language. You're going to want to have the ability to do inheritance and overriding and things like that. Structs are really more for the basic fundamental types like double, int, array, dictionary, string. These are all, really fundamental things. And when we get into the graphics, you're going to see that points, sizes, rectangles, those are structs, okay? But most of everything else we build with classes, okay? And since it manages all the memory for you and all that, it's really no big pain to use classes. All right, so methods. So I want to talk a little bit about methods, all right? You obviously, if you override a method in a class, you have to put the keyword override in front of it, okay? You can also mark a method final. That means no one can override it. So if someone subclasses a class you wrote, they can't override it if you marked it final. You can also mark an entire class final, which means it's, this is the end of the line. You can't do any subclasses of it, basically. Okay? Both types and instances have methods and properties. So types, a type is like array, that's the type. An instance of an array is an actual array with things in it, okay? Let's look at this piece of code right here. I've defined a double, okay, this var, which is a double. And I say if the double is sign minus, that means if it's minus sign, it's negative, then I'm going to set the double to be the absolute value of the double. So is sign minus is an instance variable, an instance property. You send it to a particular double to ask it, is your sign minus? Whereas double.abs is a type function on double. You pass the double you want to operate on to it, and it works on it. But you're not sending abs to a particular double. You're sending it to the class, or the struct in this case, the type. You see what I mean? So some methods you send to instances, particular instances of something. Some things you can send to the type. All right? So two different kinds of method. But otherwise, the rules for them are about the same. It's just that who you ask to do the work. You declare a type method or property by using static in front of it. So like abs, there would be static func abs takes a double, returns a double. And that makes it so that you send it to the double type instead of sending it to a particular double. In a class, you use the word class, not static, okay, because it's called a class function. Okay? So I just don't want you to be confused when you start seeing methods like abs that are sent to the double type. That looks kind of weird, but it's perfectly normal. Okay? And what would you do with a type? When do you have a type function versus an instance function? Well, if you're doing any kind of utility work, right? You're not doing anything particular to a certain kind of double, but you're just doing utilities. You would have those in there. Sometimes you would have type methods that create objects of certain kinds and hand them out. Maybe a shared object, like if you had only one instance of an object for your entire app of a certain type, maybe you would ask that type, give me that shared instance. Okay? So it's kind of for utilities and creation, that kind of thing. I don't want to say they're rare, they're not super common. You'll see them in iOS, and you'll probably use them occasionally. You would use them really instead of global functions. You can have global functions in Swift, of course, but you'd really probably prefer to make it a type method so that that function is associated with, the type and kind of, unless it truly is a global function that just applies to the world, it's not about a particular class. Usually you would make them be a type function or a type variable. All right. So method. Now let's talk about the parameter names of methods. This is going to be the crash course. You read all about this, I hope, in the documentation. But all parameters to functions have an internal name and an external name. So we're talking about the parameters, okay? So down there, foo, the parameters, parameter to foo there. Okay, it has internal name and external name. So the internal name, which goes kind of near the colon, is the name that that thing is going to have as a local variable inside the method. That's its internal name. And then the external name is the name that callers are going to use to put before the colon, okay, when they call the thing. So in bar there, I'm calling things, and in foo, I'm defining them. So you see that here, I call foo with external colon 123, even though internal to foo, that thing is called internal. Okay? So you can have both external and internal names. They can be different. You can put an underbar. Remember, underbar is kind of the don't care thing in Swift. You can put an underbar if you don't want callers to use an external name. So now look at bar. It calls foo. It doesn't even put internal colon or external colon. It just puts the argument there. Okay? So the underbar says, I don't want to have an external name for this. Okay? Now, that is the default for the first argument to a function. So foo only has one argument, so its first argument, its only argument. You can see that when you call it from bar, you don't say internal colon. That's because that underbar thing is the default. Now, if you don't want that to be the default, you can force the first one to be required by putting a pound sign there, a little hashtag. Okay? And that makes it so you have to say internal colon. Okay? For other parameters, not the first parameter, but other parameters, the name, the internal or an external name, is mandatory, okay? Unless you put the, and you can change the name. It can be, you can have the external name be different for any parameter, not just the first one. And you can put the underbar in there and make it so even the second one has no parameter name. This would be incredibly un-Swift-like to do this, to have a function like this that takes two arguments and the second one doesn't really have a name. Because in Swift, you can kind of think of the name of the method as describing what the first argument is. The first argument to your method should always be kind of obvious based on the name of the method, because the method does something, it operates on something or whatever. That should be the first argument. That's why it usually doesn't need a first parameter name. And then all the other arguments, you want to give them names so people understand what they are, okay, what they're about. And in other language, a lot of times you'll have a really long method that says, you know, do this and that with this other thing and that. And then in parentheses, you have 4 arguments, and people have to kind of match up what's what. Here, the name of the method really is kind of distributed out amongst its arguments, so it's really a lot easier to read and a lot easier to understand what the heck is going on. So I don't recommend it. I don't recommend putting the underbar in parameters. There are some exceptions, but I generally don't recommend that. Okay. All right. Properties. Let's talk a bit about properties. So property observers are very important, and we're going to use them a lot. They are very simple. You have a property, like here I have some stored property. It's an int equals 42. And yes, I didn't need the type there. I'm just putting there. Okay, and throughout all my slides, by the way, green, I put things in green because I'm just trying to make you draw attention to the fact that this is code. Okay, that's all green means. But yellow usually will mean this is the thing I'm talking about right now. This is the thing to pay attention to. So you can almost think yellow is like highlighted, okay? So here I have some stored property. It stores an int, 42. And notice though, even though it's a stored property, not computed, it's stored, I still put curly brace after it. But in that curly brace, instead of saying get and set like a computer property, I say will set and did set. Okay, so these are little pieces of code inside the will set and did set. They get called when that property gets set by anybody. So it's called a property observer because I'm observing, with this code, I'm observing this thing is being set. And the will set is called right before the property's value gets set, and the did set right after. And inside the will set, you got this special variable called new value, which is going to be the new value that's going to be set. And then inside did set, you've got this special thing called old value, which is the old value. Okay? Now, you use this in really kind of these two cases. One is you have a stored property in yourself, in your class, and whenever someone sets it, you want to kind of notice and do something. Okay? And the other one is you inherit some property, and you don't necessarily do anything with that property directly, but you want to know when that gets changed by anybody. Okay? So you can even do will set and div set on properties you inherit from somebody, from your superclass. Okay? Now, what kind of things would we do in here? Well, one extremely common thing to do in iOS is to update the user interface. So you have some view controller, let's say, or you have a view, and you change some property in it, and changing that property means the UI would change. So in the did set, you'll go update the user interface. Does that make sense? Okay, so the observers are really cool. They're a really good way to kind of keep track of what's going on and keep things in sync. All right, lazy initialization. So a lazy property, if you put lazy in front of a property declaration, it means it does not get initialized until someone accesses it. And that's true whether it's initialized with equals something. So that equals something will not happen until someone actually accesses that property. Or you can actually initialize it by putting a closure there, put parentheses after it, and it will execute that closure. And that will initialize the property. But that closure won't get executed until someone tries to get it. Okay? And then you can even, in a lazy property, you could call a method to initialize it, because normally you wouldn't be able to do this if you didn't say lazy, because you can't call any methods in your class until you're fully initialized. So there's kind of a catch-22 there. But in this case, since you can't call any methods until you're initialized, by the time someone tries to get this property, you'd be fully initialized. So you can call methods. So you see the advantage of lazy there? Okay? This lazy thing still satisfies the rule that you must initialize all of your properties. Okay? Even though it doesn't actually initialize it until someone accesses it, it still satisfies that rule. Unfortunately, only vars can be lazily initialized. Things that are let, if you had constants in your class, those would have to be initialized in your initializers. You can't initialize them lazily. Only vars, not lets. This can be used to get around some kind of tricky initialization dependencies. Because of that rule that everything has to be initialized before you can do anything, sometimes you can get into fights with your superclass, for example, about when something's going to be initialized, and you need your superclass to do something before you can do something, but it needs you to do something before they can do something, so you're kind of, we're stuck. And what you can do is one or the other of you make one of the things that depends on their lazy. Okay? And then as soon as somebody wants it, it'll get initialized, and off we go. Okay? Any questions about lazy? Pretty cool feature, right? And it's exactly what it sounds like. It just lazily waits to initialize until someone wants this property. Okay? So now let's talk about initialization. So I need a drink before the initialization, because it's complicated. Hopefully, this is not just my voice here. Okay. Init. All right. So when do you need an init method? Well, you know what? You actually don't need an init method that often. Okay, we should have the init method in the calculator brain. Made sense there. We needed it there. But you don't need that often, because a lot of your variables and constants in your class or struct are set with equals. So you don't need them. Or maybe the properties are optionals. And so they can just start out nil, and you set them later, okay, like the outlets in a storyboard. Or you can actually initialize by using a closure. Okay, as I showed on the previous thing, that lazy thing, that you can do that for non-lazies, put the closure thing there and execute it. It'll get executed right away, and nothing inside that closure could refer to any other instance variables, of course, because it would be executing before the initialization was done, but still, you can calculate some things to assign things in a closure by executing a closure. Or you could just use the lazy mechanism and then to avoid needing an init. So there's a lot of ways to avoid init. But if you do need an init, then how do we do init? Because init has some kind of interesting interdependencies. It's not as straightforward as you might think. Now, you get some free inits, okay, inits that get done for you. One is that if all the properties in a class, in a base class, something that has no superclass, like calculator brain, if they all have defaults, then you'll get an init with no arguments for free. So if we hadn't implemented calculator brains init, of course, we still could have said, you know, brain equals calculator brain parentheses. That's because we got a free init in calculator brain because we initialized all our defaults using equals something. Okay, so that's one way to get an init. A struct, not a class, but a struct, it will get a default one that has all the properties as arguments only if you have no initializers. So if you had a struct and you gave it no initializers, you would get one for free, which would be a init, where all the arguments match all of the vars you have, all the vars and lets. Okay, so like here I got a struct. It has two properties there, x and y, and you can see that I got this init. X takes an int and a y string for free. I didn't have to implement that at all. It just came for free. And so people can call that. They can initialize my struct by saying my struct, open parentheses, and provide the x and the y. Okay? All right. So what can you do inside of init? Okay, we saw what we did in calculator brain. We initialized some stuff. But what can you do? Well, you can set any properties value in there. You can even set properties that have default values. So even if you have a property and you said equals 12, in your init, you could reset that thing to something else if you wanted to, if you changed your mind in init. Okay? You could do that. You can also set constant properties. So if you have a struct or a class and it has let x colon string, you can set that in your init. Even though it's a let, it's got to get set sometime. In your init is when you can set it. You can also say equals something, but you could also set it in your init. Okay? So people sometimes don't realize, like, oh, I can have lets in my class. I can have, like, you know, constants for my class that are created at initialization and stay the same for the whole lifetime of my instance. And absolutely you can. And you initialize them in your init. Okay? That's actually good practice if you have something that's, you know, constant like that. You can call other init methods in your own class or struct using self.init. Okay? Self.init, you can call the other ones with the ones that have different arguments. Okay? So that sounds good. And of course, in a class, you can call super.init. Call your superclasses initializers with their arguments, whatever they might be. However, big old humongous however on this one, there are a lot of rules for calling other inits, especially in classes. Okay, in structs, it's not a big deal, but in classes, there's a lot of rules, and we're going to take 2 slides here to go through these rules briefly. All right, so as part of these rules, what are you required to do inside of init? What is mandatory for you to do? Well, as you know, you have to have initialized all the properties in your entire class. You cannot start a class off with no values. And remember, optionals, nil is a value for an optional, so if an optional is nil, it is set, so everything's fine there. There are 2 types of inits in a class, not in a struct, but in a class. One is called a convenience init, and then there's all the other kinds. Those are called designated initializers. So by default, an initializer is called a designated initializer, but there's also these things called convenience initializers. And we make this distinction because there's a little bit different rules about them, so let's talk about that. A designated initializer, one that doesn't say convenience in the front of it, it has to and can only call a designated initializer in its superclass. It's a very important rule. Okay, if you have a designated initializer doesn't have the word convenience in front of it, it can't call another init in your class. It has to call a superclass's init, and it has to be in a designated initializer, not a convenience initializer, in the superclass. Okay? Understand that rule number 1? As for designated initializer. This is all, by the way, in the documentation. It's very elaborately drawn out with pictures and all that. I'm just trying to summarize it here. Okay, hopefully you've read that already, and this is review, but if not, hopefully understanding a little bit of what I'm saying to now, when you read it, you'll say, oh yeah, I get it. Okay, so that's the rule for designated initializer. You have to initialize all of your own properties before you call your superclass's initializer. Okay, this is for designated initializers only because they're the ones who call their superclasses initializers. So you have to be done with your own properties before you call your superclasses. This one will trip you up often. Okay? You also have to call your superclasses init before you assign a value to any property you inherit from your superclass. In other words, you have to let your superclass initialize its properties before you can start setting them. So you get those three rules. Okay, that has to do with your super. It has to do with designated initializers and calling super. All right, now a convenience initializer has different rules. Okay, first of all, a convenience initializer must and can only call a designated initializer in its own class. Convenience initializer cannot call super init of any kind, and it can't call, and it must call a designated initializer. Now, it can call that designated initializer indirectly through another convenience initializer. Okay, so one convenience initializer could call self another convenience initializer, which could call a designated initializer, but eventually a designated initializer must be called. Okay. A convenience initializer must call that designated initializer, directly or indirectly, before it can touch any values, obviously. Okay? You have to kind of get your object primarily initialized before you can have the convenience initializer start hacking at properties. The calling of other inits, whether you're a convenience guy calling your designator, or whether you're designated calling up to your super's designator, has to be complete before you can start accessing your properties and methods. In other words, the class has to be initialized before you can start calling methods and properties. Okay? That's why we have to use lazy if we want a property to set its value to be calling a method, because we can't do it non-lazily because we wouldn't be initialized at that time. We'd still be in the process of initializing. It's kind of a two-phase initialization. You get fully initialized, now you can go do that. Okay, so these are the rules. Question?
Is there a way to set a constant then by like calling a method? Like,
so the question is there a way to set a constant by calling a method or something like that? And the answer is no. Okay, you can only set constants either setting them equals something or in your initializers. Unfortunately, later you can't do it. Okay, let's talk about inheriting init. Okay, because this is complicated as well. So here are the rules for inheriting init. If you do not implement any designated initializers in your class, then you will inherit all of your superclasses' designated initializers. Otherwise, you will inherit none of your superclasses' designated initializers. Okay? It's all or nothing on designated initializers. If you override all of your superclasses' designated inits, okay? So your superclass has 3 designated initializers with different arguments. If you override all of them, then you will inherit all of your superclasses' convenience initializers. Also, if you implement none of them, because you'll essentially inherit all the designateds and all the convenience in that case. Okay? So that's the inheritance rule. And this trips people up too. They're like, oh yeah, I implemented that one initializer, but how come the other initializer doesn't work? Well, because once you implement one designated initializer, you don't inherit the rest of them. Okay? So it's all or nothing on designateds. On convenience, it's kind of all or nothing too, because you have to implement or not implement all of the designateds to get the conveniences. Any init that you inherit by these rules that I just said count for all the rules on the previous slide. Now, I'm not going to go back to the previous slide and go through them all, but you can satisfy a lot of the requirements in the previous slide by just inheriting your initializers. Okay? But you can only inherit them in these kind of restricted ways, but once you do, you can satisfy a lot of those previous rules. It is possible to have what's called a required init. You just put required on it, and if you put required, it means that subclasses must implement it. It is required. Now, they can inherit it by the rules above. In other words, if they don't implement any designated initializers, they'll inherit the required initializer. That's good. But if you implement any of the designated initializers, you must implement the required ones. Okay? Finally, there's failable initializers. Okay? So some initializers are allowed to fail and return nil. Okay? You designate them by putting question mark after the init like this right here. Okay? Now this is pretty uncommon. Okay? You don't see this very often. And the documentation, last I checked, doesn't really show this very well. It doesn't put the question mark in there. I think it's just a documentation generation problem. It will say in the comment for the init, this can return nil if it fails, but it doesn't seem to put the question mark on there. But that's okay, because when you start using it, you're going to call this initializer, and the thing's going to come back, and you're going to try and send messages to it, and it's going to say, this is an optional, does not respond to the method. And you're like, what? It's an optional? And then you're going to know, oh, the initializer was failable. So let's look at an example of this. So UI image, okay? It's a class in UIKit. And it returns an image. And you can ask for an image by its name. But of course, that image named that might not be anywhere in your project. So this thing can return nil. So in this case right here, image equals UI image named foo. Image is an optional UI image. Even though I'm calling an initializer there, right? UI image is initializer. It could be changed. So usually what we do in this case is we use if let. Right? If we can let the image equal the image named foo, then we'll do what we want. Otherwise, we couldn't find it, so we'll do whatever we do in that case. Okay? So watch out for those. There's very few of them, a few dozen at the most. Yeah?
Does this replace like try catch?
So the question is, does this replace try catch? We're not even going to talk about try catch in this class. Okay? That's how rare it is. You really don't even use try catch in Swift. You know, things are, optionals make a lot of try-catch stuff just not necessary. Try-catch, for those of you who don't know, is you can raise exceptions in your program, and they can percolate up the call stack, and someone tries to catch them and handle them, okay? And that programming methodology is not one that's really something we use very much in iOS, okay? In Objective-C, maybe it was used even a little more. I'm not even sure about that. But certainly in Swift, we're not going to be using that. I'm not even going to show it to you in this class. That's how unnecessary it is to know that. Okay, so let's talk about creating objects then. You know to do it by putting the type and then parentheses and then the arguments to the initializer. Okay, it's completely obvious there. You notice you don't always create objects by doing that. Sometimes you will ask a class method or a type method to do it. So here's one, button with type. You see that's being sent to UI button, the type. Right? It's not being sent to a UI button. It is being sent to the type, like we talked about before. And so sometimes you'll be creating things that way. Very rarely. Apple's been moving away from that model and more towards just using initializers and creating things. But there's some that do that. Like remember UI image on the previous page, that wasn't UI image.image named. That's kind of how it used to be in Apple. Now it's UI image, parentheses, whatever, call the constructor. Sometimes other objects will obviously create objects for you. So like here's a really cool method in string called join. Okay, join takes an array of strings and it will separate them by whatever string you send join to. So comma.join of an array will give you a comma-separated string, a string with the things in the array comma-separated. And that's obviously creating a new array. So this is kind of completely obvious, but yes, some methods return objects to you that were created. OK, so now let's talk about any object. This was brought up earlier. Any object is kind of a, OK, for the purposes of what you know so far, you can think of it as a type. Okay? It's not really a type, but you can think of it as type, like double or array or whatever. And it's used primarily for compatibility with existing Objective-C APIs in iOS. Okay? You're really not going to use any object to build your own data structures very much. I suppose you could, but it'd kind of be, again, kind of anti-Swift. Swift is very much into strong typing and type inference and all that. So you could, but I'm only going to talk about it in the context here of using it as this compatibility thing. All right? So what is any object? Okay? And where will you see it? So any object means a pointer to an object, meaning an instance of a class, okay, that you don't know what the class is. So it's just kind of pointer to unknown class, okay, which seems kind of weird, and it is kind of weird. So we're going to have to play around to be able to use it. But that's what it is. And where will you see this in iOS? Sometimes you'll see properties that are any object, like there's a property on storyboard segues, which we're going to talk about next week, called destination view controller, instead of being a UI view controller, it's a type, it's any object, okay, for historical reasons, really. And similarly, in UI view controller, there's a property called toolbar items, and it returns an array of any object, okay? So basically, these properties are giving you back things you don't even know what they are, okay? You'll also see them as arguments to functions. Like here's a UI view controller method prepare for segue. It takes a normal argument there, segue, but then it also takes a sender, which can be any object. Now in that case, it kind of makes sense because it really could be any object in that case, because whatever's causing the segue to happen in your user interface could be any object, so it would make some sense. But there's add constraints, okay, which is another UI view controller thing. And you add the constraints, you think that would be array of whatever class constraints are. I haven't taught you about this, but these are the constraints that do all our UI shifting. But again, for historical reasons, it's an array of any object. And even in append digit in calculator, okay, remember when we control dragged the button to make append digit? And I made a big deal of saying, change that from any object to UI button, okay? Well, if you hadn't changed it, then you could have ended up with append digit sender any object, okay? It also can even be the return type for functions. Like that button with type I talked about a few slides ago, it actually returns any object. It doesn't return a UI button. You'd think it would, but it doesn't. It returns any object. Okay, so this, you're probably like, what the heck is going on? Why would we be passing around these pointers? We don't even know what these things are, okay? Well, we'll talk a little bit why we do it, but let's talk first about how we use it, because it's this pointer to unknown object, so I can't really send any messages to it because I don't even know what it is, okay? And so to use it, we convert it to a type we do know. Okay, that's the only way we're really going to use any object is to convert it to some class that we do know, right? And we do that with by creating a new variable. So we've got some any object. It was an argument to a method, or it's a local variable, or something like that, and we want to convert it. So we're going to create a new variable of the type we want to convert it to. Okay, and we're going to assign this new variable to be equal to that any object thing converted. Now, of course, we have to convert it to a compatible type. It actually has to actually be one of those things. So if we got the UI button back from button type and it comes back as any object, we can convert it to UI button because it is a UI button. Okay, but we can't convert it to a UI label. It's not a UI label, so that would crash our program actually. So how do we do that conversion? Yes, yeah, we crash our program if we do that. How do we do that conversion safely so we're not crashing our program all the time? So there's two ways, and we call this casting, okay? You know what type casting is. We're essentially casting the type from any object to something else. And we can typecast forcibly using the as keyword, as. Okay, Swift, as usual, very succinct. And so I'm going to use that destination view controller thing as an example. So I've got this property, destination view controller. It's an any object. And I know it's a view controller, and I think it should be a calculator view controller. So I'm going to be using in my examples calculator view controller. Imagine we had called our calculator view controller instead of view controller. I'm doing that in the examples because it's just going to make more sense, okay? So I want to talk to this destination view controller, which is any object, and I know that it's a calculator view controller. And if it's not a calculator view controller, my program should probably crash, because in the context I'm using it, I want it to be that, okay? So I can just say let calc_vc equals calculator view controller as calculator view controller, and now calc_vc, this new constant, its type is not any object, its type is calculator view controller. And so now I've gotten hold of that any object in a way I can actually do things with it, and I can send messages, calculator view control messages to calc_vc. Now, you can protect against crashing if you're not sure whether that destination view controller is a calculator view controller, but you're hoping it is, okay? You can use as question mark. And as question mark returns an optional. Same as, right? As returns that any object thing cast to be a different class. As question mark does the same thing, but it's optional version of that. So it can return nil if that any object, destination view controller, cannot be turned into a calculator view controller because it's not a calculator view controller, it's some other kind of view controller or something else, all right? And so you can say if let calc VC equals destination view controller as calculator view controller, and then inside there you've got calc VC set, and it's, you know that it's a calculator view controller, and any object is now in your past, okay? Make sense? So we get as and as question mark. You can also check beforehand if you just want to see, is this a calculator view controller? You can say is. So you can say if destination view controller is a calculator view controller, then I'll go ahead and then I can do the as, for example. But usually we use the as question mark, and, check it and convert it all in one go. Okay? So that's how we're going to use an any object. We're going to have to cast it with as into something else. Question?
Is there a method which tells you what type it is? Because if it's able to check if it's not or if it is, it does know it under the code, right?
Yeah, so the question is there a way to kind of ask it what the type is and get the answer back in some way? And the answer is, for the purposes of where you are, no. Okay? You don't do that. You ask it for certain, whether it can be a certain thing. You don't ask it, what are you? And then try and figure it out from there. We're not going to use that paradigm. Okay. Let's talk about arrays of any object. Because sometimes you're going to get an array of any object back, like that constraints one I was talking about, where it's going to be an array of constraints that are going to be any object, but I know they're going to be NS layout constraints, but they're going to be an array. So you can do some interesting things with casting there. So let's use the toolbar items one. So that toolbar items, that's a property in UI view controller, and it returns an array that's going to have UI bar button items in it, but for historical reasons, it returns this square bracket of any object. So I can say for item in toolbar items, then item is going to be an any object. So I'm enumerating those any object, and I'm actually having my variable item be any object. But then inside, I'm saying if I can let the toolbar item equal, be a UI bar button item, then I'm good to go. So you see how I'm enumerating this array of any objects, and then inside I'm doing the as question mark. But I can do it another way too, okay? Which is I can say for toolbar item in toolbar items as an array of UI bar button item. In other words, I can cast the entire array. If I know that that array of any object is really an array of UI bar button item, I can just cast it. Now this one, you can't do question mark, because it wouldn't make sense to say for toolbar item in nil, okay? So that makes no sense. So you can't. Here you better be darn sure that that array has what you want. But then inside, now toolbar item is a UI bar button item because I casted the whole array from array of any object to array of UI bar button item. Understand the difference there between those two? Okay. Another example of any object and where it appears. So if we hadn't changed, when we control drag to make append digit, what if we had left it any object? Okay, so we had append digit sender : any object. How could we have dealt with that? Well, we just would have said, if we can let the sending button equal sender as a UI button, then do what we do. Let digit equal sending button dot current title, exclamation point, et cetera, et cetera, et cetera. Make sense? But we didn't want to put that extra if let, and I hadn't taught you about as, so that's why I said be sure to put that thing UI button. All right? Now you might ask, why is that even in any object? When I control dragged, why didn't it just put UI button? Why did it even offer any object? Well, because you could have an action that is sent by two different kinds of UI elements. Maybe it's sent by a button and also by a slider. I don't know how that would be. I couldn't even think of an example of that, but you possibly could. It is theoretically possible. And in that case, the sender would be any object, and you would have to say, if the sender is a slider, then do one thing. Else, if the sender is a button, then do something else. And you would do that with as. Okay? So that's why I'm saying I think that default should not be any object, because that's a pretty rare case where two different kinds of UI elements are sending the same thing. So why do the rare case? Even though that's the more generic or more general case, I agree, it still just seems kind of error prone to me. But anyway, so there's another any object example. So here's one more any object thing. Let's go back to that button thing. So I told you the button with type returns any object, okay? And so if I got a button and I wanted to find out its title or something like that, I have to cast it. So I would call I would call that button with type, and I can cast on the fly, right in line. So if I called that line on green at the top, then down here I could say the title of the button equals button as UI button dot current title. So I'm just casting that any object, that button any object up there to be a UI button, and then sending it a message. So you can cast on the fly. Again, crash-a-roo if that button is not a button, but that's okay. In this case, button with type better darn well return a UI button. Okay, now this casting business is not just for any object. You can actually cast any two objects. For all non-any object case, though, obviously those two objects would have to be in the same inheritance hierarchy, right? You can only cast down, downcast into your own inheritance hierarchy. So, for example, if I had a local variable called VC, which was of type UI view controller, but I set it to calculator view controller, okay? I couldn't say vc.enter, right? Enter is a method in our calculator view controller. I couldn't say vc.enter because VC is a UI view controller. So as far as Swift knows, it doesn't respond to enter. Even though it is, in fact, a calculator view controller, from Swift's point of view, that local variable is not. It's of type UI view controller. But I could cast it and say, if I can let the calc VC equal VC as a calculator view controller, now I can say calc VC.enter. Okay? So you can cast, downcast through your inheritance hierarchy as well. You rarely do that, but might occasionally. All right, so let's zoom on here to any questions about that whole any object thing. When you see it in action, it'll make a lot more sense. Okay. Okay, so now let's just talk about some fun functions throughout all our classes, and we're going to start with array. First of all, that you know that array does plus equals. You can say array plus equals, but the argument to plus equals is another array. Okay, so if you just want to add one thing to an array using plus equals, you would have to put it in another array, just square brackets, put the thing inside, okay? Some people get tripped up by this. They do plus equals, they have an array of ints, and they say, my array of ints plus equals an int, and they're like, wow, why doesn't it work? It's because plus equal only adds a whole arrays to other arrays. It's an array concatenator, okay? There's a couple of interesting variables, properties in array, first and last, that will return the first or last item in the array. What's interesting about them is that they return an optional. So they don't do array index out of bounds. So they'll return nil if your array is empty. Okay? So you should know about these because they can make your code read really nicely sometimes. So for these next ones, I'm going to have a little example array here. This is going to be an array that's got 3 things in it. I'm not even going to say what the types of those 3 things in there. They could be anything, okay? Because array is generic, right? Array angle bracket T. You can assume for the purposes of this, they're of type T, whatever the T is that I created the array with, right? So let's talk about, about append. That's how you add something to array. We did that in the calculator all the time. There's also insert. So you can insert something in the middle of your array. You just specify what index. There's also splice. Okay, splice will take another array and splice it into the middle of your array. Okay, so that can sometimes be valuable. It's otherwise just like insert. It's just like inserting another array inside the array. Okay. There's also remove add index, of course, if it's a var. If you've got your array in a var, you can do remove add index. There's also remove range. Okay, so you can specify a range with the ... thing or the ... less than thing and remove a range of your array elements. And there's also replace range. And when you replace a range, the thing you replace it with doesn't have to be the same length. So I can have an array and replace a range that spans 3 things with something that is 6 long and it'll make my array longer. Okay, so I can replace range. There's also sorting. You can sort an array. The sorting method in array takes 1 argument, and that's just a function to determine whether 2 things are ordered before each other or not. Okay, so it's going through the array and putting everything in order. It needs to know, it picks out whatever sort it's using, quicksort, or I don't know what sort it's using in there, but it needs to be able to compare things. So you just provide a function that does comparison. And usually you're going to do it with a closure just like this. You can see this is kind of the default sorting, assuming that this type can just be compared with less than. I would just say a.sort, closure, $0 less than $1. Make sense? And that's going to return yes if $0 is less than $1. And that's what sort wants to know. And it's going to call that closure repeatedly, okay, as it's going through doing its quicksort or whatever. There's also another one called sorted. This is an in-place sort, right? Sorts the array in place. Their sorted will return a new array that is sorted, okay? A copy of your array sorted. More array methods, okay? So these three are pretty cool. This one's called filter. So filter will give you a new array with all the undesirable elements filtered out of there. And the way you specify which ones are all undesirable is with the argument, which is a function that just returns a bool, whether something's undesirable or not. Make sense? And there's another one you can do by mapping. So this will give you a new array where every single element in your array is mapped to something else. And the thing you map it to doesn't even have to be the same type. So I could have an array of ints, and I could map it to an array of strings. And that's what I've done here. So I have this array of ints, 1, 2, 3, and I've mapped it using a closure that returns the stringification of it to an array of strings. Now, you can see incredibly concise language, Swift. I mean, to take an array of ints and turn it into an array of strings, no for loops, no nothing, just, you know, I don't know, a dozen characters here. So you really want to take advantage of some of the things Swift can do with closures, syntax, and things like that. You can also reduce an entire array to a single value. So this one takes an argument which is the initial value you want to start with, and then it just takes a function that takes the value so far and the next element in the array, and you return what the combination is. So you're just combining, combining, combining. So for example, if you wanted to add it up an array, you could say 1, 2, 3, dot reduce, start with a 0, and then my closure is just going to add the next element, which is the $1, to so far, which is $0. Okay? All right, string. So string is a little bit complicated. I can tell by the way already I'm not going to get to the end of this, so we'll finish this next Wednesday on this whole slide package here. But so string is complicated when it comes to indexing, you know, creating substrings and stuff like that. A lot of people are like, oh, I can't even figure out how to make a substring of a string in Swift. It's so complicated. But once you understand that strings are made of Unicode characters, and when you get a substring, you actually don't want a substring of Unicode characters. You want a substring of Unicode characters that are on glyph boundaries. A glyph is something you perceive to be a character. But in Unicode, it could be multiple characters making up one glyph. For example, an accent. So, you know, a lot of European languages, there's accents. Okay, maybe, you know, in French you have accent aigu, right, which is the forward-going top slash. Well, that could be two Unicode characters, E and the accent character. So two characters makes what you perceive to be one glyph. So you can't index into this string, which is an array of characters. That's what a string is. A string is an array of, essentially internally, a collection, ordered collection of Unicode characters. You can't really index by int, or you might be halfway through the accent aigu, and you're getting, you know, either the accent aigu or the E, but not the character. So instead, strings are indexed by this other type called string.index. Okay, now how do you get a string.index? Okay, well, yes, it's saying here. Okay, so you get a string.index by getting the start index of the string. That gives you a string.index that points to the first character of the string. And then you advance it forward however many times you want to go. So in other words, you have to look through the character so that it'll jump over E accent aigu, both characters, to the next one, you see? So you do that with this function. It's not a method in string. It's actually just a function, a global function called advance. And you give it the index, okay, and you tell it how many times you want it to move forward, and it will give you back a new index. So here's an example. I have a string that says hello. Okay, I want to get the index of the L, the first L. Okay, so I say let the index equal advance the start index of that string, go forward 2. Okay, so now it's pointing at the L. It went forward 1 to the E, now forward to the L. And again, if it was E accent aigu, it would have gone forward 4 Unicode characters, but only 3 to the third glyph as you perceive it, okay? So now that I have a pointer to that L, I could use, for example, a nice string function called splice. So splice is just like the splice in array. It will splice a string into the middle of another string, okay? And I'm going to have it splice at that index, and that's going to make it be HE ABC LLO. Splice the ABC right into the middle there, okay? So the start index is the magic behind making that work. Also, if I got two local variables, start index and end index, which I made by taking advance of the start index by 1 and 6, so this is going to be, I want to be from index 1 to index 6, then I could get a substring. And I get a substring in a string exactly the same like in an array, square brackets, string, square brackets, but inside that square brackets goes a range, and the range, the dot, dot, dot thing, has to have a string dot index on the left and a string dot index on the right, not ints. Okay? So here I got a string dot index by doing this advance for the left and a string dot index on the right, and so the substring will be EABCL, because I went from index 1, which is the second character, index 0 is the first, or to index 6, not including index 6. Okay? Everyone understand string dot index now? It's all about advance. Okay? The advance function is the key to understanding how to substring strings. And there's lots of other, once you understand this, there's things like range of string. Remember we used range of string in calculator, and I told you it returned nil if it couldn't find it. Well, what does it return if it could find it? Well, it returns a range of string.index. Actually, it returns an optional range of string.index. Okay, that's how, if you used it for your assignment, that's how you used it. You used the optional nature of it, but now you could even use the range nature of it. So for example, if we wanted to get the whole number portion of a string that had a number, so I have, let's say, 56.25 as a string, I want to get the whole number part, I could just say, find me that decimal point, okay, and that's going to return a range, if it can find it, if there's a decimal point in there, it's going to return that range. And I'm going to grab the part from the num's start index. You see the num is the number, its start index, all the way to where the decimal is, not including the decimal. Okay, now I got the substring, which is the whole part. Everybody cool with that? So substringing and string is actually, once you understand this whole index thing, pretty powerful. We could even remove the whole number part, okay, just by using remove range of that same range, not start index to the decimal range. Or we can replace the range with other things, etc. Okay, so there's a lot of string methods there for doing that, and they're all based on that string index. Okay, other string methods, I'm going to start blasting through a lot of this. You can look these all up in the documentation. Some of these it actually gets from NSString, which I'm going to talk about in a moment. You can see that you can find the end index. There's that join I talked about before. Notice that there's 2 int, but not 2 double. Why is there 2 int in string and not 2 double? Anybody have an idea why that is? It's because when you convert to a double, you have to specify things. How many significant digits do you want? How many digits after the fraction do you want? Things like that. And so there's really nowhere to specify that. It would have to be 2 double with a whole bunch of arguments to specify how you want to do that conversion. When you convert to an int, there's nothing inside. You just convert it to the int, right? To the whole number. So, but notice that 2int does return an optional int. That's because if you say 2int, if you send that to hello, it's going to be nil. Okay? So, string methods. All right. Okay, there's kind of a hidden bunch of methods that you don't even know about, which is conversions using init. So, for example, if I had a double and a float, I could say let x equal int of that double. And I just basically created a floor and turned it to an int. So I converted it. So you convert things and convert them from one thing to another. It makes total sense with the number values like ints and floats and things like that. And you're going to see CG float next week. That's another kind of floating point number. And you can convert using, there's no toInt or anything. You just create a new one with the initializer. Okay, so the numbers. But you also might be surprised, actually if you read the homework carefully or the reading assignment, you saw this, is that you can convert arrays and strings using these initializers. For example, you can say array of a string, so create a new array, and the initializer's argument is a string, and it will return you an array of all the characters in that string, right? Unicode characters. Or vice versa, you can have an array of Unicode characters, right? And it will, and you pass that to strings constructor, and it'll return a string with those things zipped up. Okay? So there's kind of a hidden thing there. Notice that you can't do string of 52.5, but that's okay because you have that backslash open parentheses thing to convert floats to strings. Okay? You can do string of 52 though, because it has 2 int. It kind of knows how to do that. All right, assertions. So assertions, really valuable debugging aid. They basically take a closure as the first argument. It's an auto closure, which means you don't need the curly braces. It's kind of a funky thing, okay? So the first argument is what would be inside the curly braces of a closure. And the second argument is some string that's going to be printed out on your console, because assert, if whatever that thing that was in the auto closure evaluates to, if that's not true, okay, because you're asserting that that's true, then it's going to crash your program. Okay, and print that message out. So it's a great way to make your program crash when things that should be true aren't. Now, asserts don't work when you build your program for release, like to the App Store. When you're shipping to the App Store, asserts don't work. It doesn't even evaluate the closure, okay? It's just ignored. But for debugging, it's pretty good. So I might have a function called validation that should, at this point that I'm executing this assert, not be returning nil. And if it does return nil, then I'm going to crash here. So I say the assertion is that validation should not be nil right now. Okay? So a lot of languages have assert, so Swift does too. Okay, other functions. So there's a lot of functions, and these do not appear to be documented anywhere yet. So this slide might be your only documentation. Now, I'm sure you can find about them on the internet and stuff too, but there's a lot of functions. These are global functions, not methods. They take arguments which are hard for me to explain to you right now, but basically they take arrays and strings and dictionaries, because they take other things that arrays and strings and dictionaries are, those things. But you can look through this list, kind of interesting things. I can combine it with the thing I was talking about at the end there, with the string, passing in an array of characters. I can actually take a string, call reverse, which returns an array of the characters reversed, and then call string to push it back and call it, create a string again. All right. Objective-C compatibility. You know what? We are going to wait and talk about this next time. Very important topic, but I don't want to give it short shrift. So that is it for today. Let me quickly show you this slide. Okay, coming up, no Friday section this week. Next Monday is holiday, no lecture. Next Wednesday, I might not be talking about auto layout next week. I'm not sure. Your homework 1 was due today. Your homework 2 is already posted. Your reading assignment 2 was posted on Monday. All that stuff is due next Wednesday. If you have any questions, I'm here.
For more, please visit us at stanford.edu.